Good morning, 8th grade math students, and welcome to virtual math class. Today we're going to be talking about the introduction to exponents. So most of this should be a review from previous years, but just in case you need a refresher, here it is. So to start with, we have this thing, and I don't want to use any words because I want you to tell me what it means. So 5, let's start with easy. What is 5 in this case? 5 would be the exponent. Good job. So we have the exponent, and then 2, that would be what? 2 is called the base. And together, this whole thing would be called the term. So again, we just jumped right on in. So 5 would be the exponent, 2 is the base, and the whole thing is called the term. And as a refresher, the number that you see, the big number, that's the number you're multiplying. And the exponent tells you how many times you're going to multiply it. So if I wrote this out, this would be 2 times 2 times 2 times 2 times 2. Because what number am I multiplying? 2. How many times am I multiplying it? 5. So 2 times 2 times 2 times 2 times 2 times 2 would be 2 to the 5th power. So our goals for this video is, first, you can use exponents to describe repeated multiplication, which really is what we just did. And secondly, I can understand the meaning of a term with an exponent. So now, which expression does not belong? So our first option is 2 to the 3rd power. Option B is 3 to the 2nd, option C is 8, and option D is 2 squared times 2 to the 1st power. So which one of these is different from the others? So if I spread this out, that's 2 to the 3rd power is 2 times 2 times 2. Well, 2 times 2 is 4, and 4 times 2, well, that equals 8. So 2 cubed equals 8. B, if I have B, that's 3 squared. Well, that's 3 times 3, and that equals 9. C, it's already simplified, it's 8. And then D is 2 squared. Well, 2 squared would be 2 times 2, and that equals 4. And then I have times 2 to the 1st, or times 2, and so that also equals 8. So options A, C, and D all equal 8. So the one that doesn't belong would be B. So B does not belong. All the others equal 8 except B. Okay. Now for our first real example. So May and Andre found an old brass bottle that contained a magical genie. They freed the genie and it offered them each a magical $1 coin as thanks. So the magic coin turned into 2 coins on the first day. The 2 coins turned into 4 coins on the second day. The 4 coins turned into 8 coins on the third day. This doubling pattern continued for 28 days. May was trying to calculate how many coins she would have. And remember that instead of writing 1 times 2 times 2 times 2 times 2 times 2 times 2 times 2, for the number of coins on the 6th day, she could just write 2 to the 6th. So I multiplied, there are 6 2's here. So instead of writing it all out, that's the same thing as 2 to the 6th power. Because what number do I see? 2. How many times do I see it? 6. So the number of coins May has on the 28th day is a very, very large. Write the expression that represents the number without computing its value. So if this trend continued, how could I write this as an expression with an exponent without actually saying what the big number would be? That would be 2 to the 28th power would be what May would have after 28 days. So on this, remember from the last problem, I got that May is 2 to the 28th. So now Andre's coins lost their magic on the 25th day. So May has a lot more coins than he does. How many times more coins does May have than Andre? So first, how could I write Andre's amount that he would have? May's is 2 to the 28th, but if Andre lost his on the 25th, how would I write that? 2 to the 25th. Now, so how many times more does May have than Andre? So if I looked at the difference. So for May, I would have 228 times. And Andrea would have 225 times. So the difference there is 3, right? So except it's not 3 times more because that I still have the base of 2 to the third. So 2 to the third, that would be 2 times 2 times 2. So 2 times 2 is 4. 4 times 2 is 8. So that's actually 8 times more is what that is. A lot of the people, whenever I taught this in person, they automatically noticed that there's a difference of 3, but it's not 3 times the amount. It's 2 to the third power, which is actually 8 times the amount. What does it mean when we write 2 to the 42nd power? That would be 2 multiplied by itself 42 times. I'm not going to write all that out because that would be a huge number. Second, how many times larger is 2 to the 45th than 2 to the 42nd? This works exactly like the last problem that I did. So what would that be? Well, the difference between 45 and 42 is 3, and 2 to the third power equals 8. So it's 8 times the amount. What does it mean whenever I write 1/2 to the 42nd power? Well, that would be 1/2 times itself 42 times. So 1/2 times 1/2 times 1/2 times 1/2 times 1/2. And it would keep on going. So which is larger, 1/2 to the 42nd power or 1/2 to the 45th power? So hopefully you have an idea. Now, I'm hopefully either going to show you that you're right or maybe show you that you're wrong. So if I have 1/2 times 1/2, I can multiply straight across. So 1 times 1 is 1. 2 times 2 is 4. Now, which one is bigger? 1/2 that I started with or 1/4 that I ended with? 1/2 is bigger, right? You would rather have 50 cents than 25 cents. So let's multiply by 1/2 again. Let's keep the trend going. So 1 times 1, that's 1. 4 times 2, well, that's 8. So which would you rather have? 1/4 of a pizza or 1/8 of a pizza? Well, 1/4 would be more, right? So this is helping you see what is happening. Is it getting bigger or smaller the more times I multiply by 1/2? It's getting smaller. So my correct answer would actually be the number that's being multiplied by fewer times. So 1/2 to the 42nd power is actually bigger than 1/2 to the 45th. Because whenever we multiply by exponents, whenever we multiply by a fraction, the number actually is getting smaller the more times that I multiply it. That does conclude today's lesson. So if you have any questions or concerns about what exponents are or how they work, please be sure to ask me.